Figure 1 shows a straight line AB with A on the y-axis and B on the x-axis. AB is extended to C. Line OD is perpendicular to AB and cuts AB at point D. E is the midpoint of line OD. Okay, so let's start by determining the following, the gradient of line OD. So we use these formulas to help us in solving these questions. So to calculate the gradient of the line OD, we use this formula. So the gradient is denoted by the letter M, and let's just put a subscript OD, indicating that we need to calculate the gradient of the line OD. Okay, so we say change in y over change in x. Or we can express it in this form. We can say y2 minus y1 over x2 minus x1. As given by this formula, it implies that we need two coordinates to find the gradient of OD. So we will use the coordinate of the origin and the coordinate of D to determine this gradient. So for x1 and y1, it will be the coordinates on the origin, which are just 0 and 0. Alright, and for x2 and y2 coordinate, it will be our point D, which is 4 and -6. So now we just have to substitute these values into this formula. Alright, so our y2 is -6. Then we say subtracted by y1, which is 0. Then we divide with our x2, which is 4, and subtract with 0. So this will give us -6 over 4. And if we divide by if you divide by 2, everything we get -3 over 2, which is our gradient. So on question 4, item 2, we need the coordinate of point E. So E, as given in the information, is the midpoint of the line OD. So we will use this formula to calculate these coordinates of E. Then we need to determine these coordinates. So since E is the midpoint, we need the coordinate of the origin and D to solve for the coordinates of E. So our x1 and y1 coordinate will be our origin, which is the coordinates of 0 and 0. And then D will be our x2 and y2 coordinates, which is 4 and -6. Okay, so now it's a matter of substituting into this formula and determine the coordinates of E. So this is going to give us our x1 is 0 and our x2 is 4, then divided by 2, and our y1 is 0 and our y2 is -6, divided by 2. Alright, so since we are adding, we're going to get a 4 divided by 2, then we get a -6 divided by 2. Now let's divide by 2, we get a 2 and a -3 as a coordinate of our point E. Moving to question 4, item 3, we need the equation of the line AC, which is perpendicular to the line OD. So this is the line AC and it's perpendicular to the line OD. Okay, so from this given information, we can determine the equation of a line using this formula. Okay, so to find the equation of the line AC, we need a gradient and a point, and that point should be along AC. So in this case, the point which we have along AC is D. So this will be our point, our x1 and y1, which is 4 and -6. Great. How about the gradient now? So we are given that this line AC is perpendicular to line OD, and we have the gradient of line OD, which we calculated here. We use this information that perpendicular lines are the product of the gradients of perpendicular lines is equals to 1, -1 I mean. So in this case, since we have the gradient of the line OD, if we multiply it with the gradient of the line AC, it should give us a -1. So the good part is we have this gradient already, so we just have to make the gradient of the line AC, have a formula and determine it. So we'll get a gradient of AC just the same as -1 divided by the gradient of line OD. So let's substitute the gradient of line OD. We get a -3/2, right? This negative will cancel out, and this will just leave us with a 2/3, right? If we simplify. Okay, so we have the gradient of AC now. So let's write it. So it's 2/3. Now it's time to solve for the equation. Okay, so now let's substitute the values of the points. We have our y1, which is, put -6 in brackets, is equals to our gradient 2/3. Then our x1, which is 4. Okay, now let's simplify. We get a +6 is equals to 2x/3. Then a -2 times 4, we get an 8/3. Okay, so now let's group like terms and simplify. So we have a -8/3 and a -6, right? -6 is just the same as saying 18 divided by 3. Alright, it's because we want to make this a single fraction. So this will leave us with 18 minus 18 minus 8, we get a -26. So this is our solution. Now let's solve for question 4.4, where we need the coordinates of point B. So point B is along the line AC, and it's also along the x-axis. So because it's along the x-axis, its y value would be 0. Alright, so let's write that down, that our coordinate B, we need its x and y value. And its y value is 0 because it's along the x-axis. That's great. Now we are only left with its x coordinate. So since it's along the line AC, which we calculated, we will have to substitute its y value and then solve for x to determine its x value. Okay, so let's do the substitution. So we have our y as 0, which is equal to 2x/3 minus 26/3. Okay, so let's move -26/3 to the other side of the equation. We'll be left with 26/3 is equal to 2x/3. Because the denominators are the same, the numerators should be the same. So therefore 2x is equals to 26. We divide everything by 2, then our x value will give us a 13. So our coordinate now is 13 and 0. So let's move on to question 4.5, where we need the size of the acute angle between the line AC and the x-axis. So let's highlight that angle which we determine. This is the acute angle. So acute angle, they are between 0 and 90 degrees. Okay, so it should be between 0 and 90 degrees. So now let's solve for theta. How are we gonna determine it? So we are gonna use this formula here, which says angle of inclination is equals to tan inverse of the gradient of the line AC. Alright, so let's be a bit specific in this case. So let's indicate that the gradient which we are dealing with is of the line AC. Okay, let's explain this concept a bit. Let's say we want to find theta, right? So since this is along the y-axis, from here to here, it will be a change in y, and from this point to this point, its length will be a change in x, right? And we can say tan theta is equals to opposite, which is this length which is opposite to this angle theta, over adjacent, which is change in x. So we use the ratio of tan, which is change in y over change in x, which is opposite over adjacent. All right, and remember, change in y over change in x is gradient. So if we want to find theta, this is just equals to tan inverse of the gradient. So in this case, the gradient is of this hypotenuse side, in this case, which is the line AC, hence we said is the gradient of AC. Now, with that cleared out, let's find this theta. So, the value of the gradient AC is 2 over 3, which will give us a value of 33.69 degrees if we leave it to 2 decimal places. So, on question 4.6, we need the equation of the line passing through E, which is parallel to the line AC. So, let's highlight that line on the diagram. So, this line is the one which we need to determine its equation, which is parallel to the line AC and passes through the point E. So, to determine the equation of a line, we use the formula here as given, which implies that we need the gradient and the point x1, y1, which is along the line. So in this case, we use the point E because it's along that line, and the good part is we already have that coordinate. So let's write our point E, which is 2 and -3. Then how about the gradient? What will be the gradient of this line? And from this given information, we observe that parallel lines, they have the same gradient, which means the gradient of the line AC is also the gradient of this line passing through E. So our gradient is going to be equal to the gradient of AC, which is 2 over 3, as we already highlighted it here. Alright, now let's solve and determine this equation. So we have y minus the y coordinate, which is -3. So don't forget to include it in brackets, and our gradient, which is 2 over 3, then in brackets x minus the x value, which is 2. Okay, now let's simplify. We have y plus 3 is equals to 2x divided by 3, then -4 over 3 if we multiply with -2. Okay, now let's group like terms. We get a 2x over 3 minus 4 over 3, then a minus 3. So -3 is just the same as 9 over 3, right? Because we want to make this a single fraction. This will leave us with 2x over 3, then minus 4 minus 9 will leave us with a -13 over 3, which is our solution. On item 4.7, we need the length of line AD from this point A to D. Okay, so we're going to use this formula where D is denoting that is the length from A to D, and we need coordinates of these 2 points. So we already have the coordinate of the point D. Well, let me just call this length AD so that we won't confuse it with this point. So we are emphasizing that we need the length from A to D. Well, let's just include the modular signs. All right. So the point D is coordinates 4 and -6. How about the point A? This point is along the y-axis, and as long as it's along the y-axis, its x value will be 0. So that's good because we have the x value now, which is 0, and we need to determine its y value. So to find its y value, since this line is along the line, this point is along the line AC, we use this equation of line AC to find the y value. So we are going to substitute 0 in place of x and so for y. So let's just do likewise. So in place of x, just put a 0, and this will evaluate to a -26 over 3 as our value of y. Alright, so let's make this our x1, y1, and this our x2, y2. Now let's solve our problem. So we need the length from A to D. Now let's substitute. We have x1 is 0, then we subtract the we have x2 is 0, then subtract with x1, which is 4. Then we square, then we say plus our y2 is -26 over 3, I mean. Then subtract with our y1, which is, we will have to put this in brackets, -6, then everything in brackets, we square it. Okay, so this will leave us with a root of -4, then we square it, plus the second bracket we have negative 26 over 3 then plus 6. So 6 is the same as 18 over 3. Then we square everything. So the reason why we express it as 18 over 3 is because we need to make this a single fraction. So if we say negative 26 plus 18 will leave us with a negative 8 over 3. Okay. So now if we say negative 4 squared, we get a 16. Then we say plus. Then negative 8 squared, we get a 64, right? Then divided by 9. All right. So we say 16. As I'm going to leave this inside form. So 64 divided by 9, we get something along 7,1, 1, 1. So I'll just leave it as 7,1. And if we add this, we get a root of 23,1. So this will be our solution. If you like, in this case I don't have a calculator, you can punch the root of 16 plus 64 over 9 and you get a decimal value, and which is not in set form.